In this episode, I want to obtain two integrals which can be found by differentiation. And the two integrals in this episode are, first of all, the integral between 0 and infinity of sine ax divided by x dx, and secondly, the integral between 0 and infinity sine squared x over x squared dx. Both of these integrals appear quite frequently in various branches of advanced maths, physics, and engineering. Right, now the first of these, I'm going to use a method which was suggested in a book, I think, which was published around about 1890. So it is not a recent discovery, it is quite an old method. So what I've done is put f of b equal to the integral between 0 and infinity, e to the minus bx sine ax dx over x, which would be the same as our integral if the exponential part weren't there. Now, if you differentiate with respect to b, we get the integral between 0 and infinity, e to the minus bx sine ax dx, which, using integration by parts, is quite easily shown to equal minus a over a squared plus b squared. So we now have f of b will be the integral of that, okay, minus integral a over a squared plus b squared db, which turns out to be minus inverse tan b over a plus some constant c. We've got to find the value of that constant, and we can find it by putting a equal to 0, which will make f of b equal 0, and so 0 will equal minus tan inverse infinity plus c, and tan inverse infinity is pi upon 2, which will make c equal pi upon 2. And so we've got our original integral, e to the minus bx sine ax over x dx between 0 and infinity, equal to pi upon 2 minus tan inverse b upon a. If we put b equal to 0, that gives us the integral that we really want, which is the integral between 0 and infinity sine ax over x dx equal to pi upon 2. And notice that this final value does not depend on a. Now let's turn to the second part. Well, the first time I saw this integral, it was derived in the text that I was reading using Fourier transforms and other very esoteric methods. I looked at it and thought, no, it can be done much more easily. So what I've done entirely by myself. So if anybody finds any mistake in it, you can please let me know. So what I've done is I've let f of a equal infinity, the integral between 0 and infinity, sine squared ax dx over x squared. And differentiating with respect to a, that becomes the integral between 0 and infinity, 2 sine ax cos ax times x dx over x squared, which simplifies to the integral between 0 and infinity, sine 2ax over x dx, which is the same as the result of part 1, and so it's equal to pi upon 2. Okay, so then integrating, f of a will be the integral of what we've just found. So the integral of pi upon 2 integrated with respect to a, which quite easily, of course, is pi a upon 2. I've not added a constant because a and f of a vanish simultaneously. Putting a equal to 1, we now got what we want, which is the integral between 0 and infinity sine squared x over x squared dx is pi upon 2. And that finishes this little exercise. Thank you very much for listening.